Hello there. Today we'll talk about some practical examples of power. We already established some fundamental concepts on power in our previous class. So if you missed it, you can go over to the platform and you have a well-detailed explanation on power. So for this class, we'll discuss some examples of power. The first example we have over here is a man raises a load of 50 kg to a height of 15 meters in 60 seconds. The question is, find the average power required. Now, if you see a particular problem like this, the first thing you have to do is to list your parameters. So if you want to solve this, the first thing is we're given the mass of the load, which is 50 kilogram, and we have the height, which is seen as the vertical distance. So you can say D, or height, is equal to 15 meters, and the time taken is seen as 60 seconds as our time. Now, stating out the parameters will help us in knowing the particular formula to use in solving this particular problem. Average power, as we know, is equal to the average power is the work done or the energy expended all over time. But in this particular problem, our focus is on the work done. So work done is equal to the product of the force and distance. So we have F times D all over time. But what is the force? We're not giving force in this question, but we're giving the mass and the height. Of course, let us take G, the acceleration due to gravity, as approximately 10 meters per second squared. So if we have this, we know that force is equal to mass times acceleration due to gravity times height all over time. So if you impute the formulas, the parameters into this particular formula, we have 50 times 10 times 15 all over. The time taken is 60 seconds. So if you punch your calculator and get the final answer, we realize that the answer is equal to 125 watts. This is the final answer. So the implication of this is that the average power required by this man to raise a load of 50 kg through a height of 15 meters in 60 seconds is 125 watts. And that's the final answer. Let us go over to the second question we have for today's class. So the question is, a car of mass 1000 kilogram is traveling along a straight road at a constant velocity of 15 meters per second. Now, the engine then develops 3 kilowatts. Calculate the force resisting the motion. Calculate the force resisting the motion. Like I said earlier, the first thing to do is to bring out the parameters, which will help us to know the particular formula to use for the question. So solution, we have the mass of the car to be 1000 kilogram, and it is traveling along a straight road of a constant velocity. So the velocity of the car, the motion of the car, is equal to 15 meters per second. And now we're told that the engine develops the power of 3 kilowatts. Now the force is what we are looking for. Now, what is the relationship between all these parameters? We would know that power, we have that power is equal to the work done per second by the engine, actually. So we have work done per second by the engine. And this work done per second by the engine is also equivalent to the force times the distance per second of the car. So we have this relationship, work done per second by the engine equal to the force times the distance per second of the car. And since this is said, we can say that the power, which is 3 kilowatts, and we said that 3 kilowatts is equivalent to 3,000 watts, is equal to, we have 3,000 is equal to the force times the velocity of the car per second, which is still the same thing as the distance covered by the car. So we have 15. We have, if we make F the subject of formula, I have divided by 15 all over 15. So the force will now be equal to, after these cancels, our force will be equal to the value 250 Newton. So the force that is resisting the motion of this car along the straight line is 250 Newton. Now this is the end of the class on the examples of power. Subsequently, we will solve more problems on this particular concept called power. So till we meet again, bye for now.